from animal intelligence, all of the different aspects of intelligence to really deeply understand that. Also, obviously, what had been done already in the field of AI. So I felt that was necessary to understand intelligence deeply to be able to build intelligent systems. So in 2001, I actually then coined the term artificial general intelligence, or AGI, together with two other people. We wrote a book on the topic, and that is what that's all about, is to take AI back to the original dream of the founders of the field of AI of 60 years ago, when AI was really all about building thinking machines, thinking learning machines that could think and learn and reason the way humans do. So 2001, so I coined the term, started a company to start building various prototypes for this technology. 2008, by 2008, I actually commercialized the first version of it in a company called Smart Action in the call center space. And I found, though, that I was getting bogged down with scalability, redundancy, HIPAA compliance, and all of the kind of technical details. So 6 years ago, I exited the company to start Aigo.ai. Again, had a new set of researchers working with me. And for 5 or 6 years, we really just concentrated on moving the intelligence to the next level. And last year, we started commercializing the second generation of technology in Aigo AI. So that's just to give you a bit of the context. And really what I'm interested in is how can we use AI, advanced AI, to have much more intelligent conversations. And there are so many different applications that can benefit from meaningful, deep conversational AI. In e-commerce, you have a shopping assistant, for example, that remembers the kinds of things that you like, that you don't like. If you buy gifts, who you buy them for, and on what occasions, how much money you want to spend, and it can be hyper-personalized to you, to the individual, that you're not just a statistic, you're not just a demographic. It remembers the conversations you've had before, and so on. So there's obviously a big demand for that because call centers are notoriously bad because it's just really, really hard to motivate people to sit there and answer phone calls all day long. The second image on here, where it says ERP, is about using conversational AI as a front end to software. So for example, if you have a business intelligence software package, ideally, you just want to be able to talk to it and say, give me the sales for the last 3 months in Europe, sorted by rep or something like that. And the system can then work out for you what it needs to show you. And then you say, show me the comparison to last year, and it will do it without you having to go down menus and fill out forms and things like that. Or another application there would be for Salesforce. Salespeople are notoriously bad at updating Salesforce. So if you could just talk to the system and say, tell me about my next appointment, and what are they interested in? What are their hobbies? Do they have any kids? Whatever information the system may have about them. And then when you're done with it, you can just say, set this to high priority, remind me next Tuesday to follow up. Send them brochure X, and let my boss know what's going on. So that kind of conversational interface to enterprise software would be very helpful. I've already touched on help desks. Obviously in the medical field, whether it's for helping people manage diabetes or whatever, to have a coach, to have a personal coach that you can talk to and interact with. Fintech, banking, VR, AR and VR applications. You basically ideally want to use your voice to interact with the system and tell it what you want to look at or things you want to change in the VR AR environment. Gaming, we've had interest, companies using it as a gaming coach. And also to make the characters within a game more interesting. If you could actually have a real meaningful conversation with a character inside a game, that would be awesome. Media applications, and many different media applications, automotive, being able to actually talk to your car in a meaningful way. Again, that it would be personalized. It can understand, much more complex instructions. And as autonomous cars come about, you could then also do work while the car is doing the driving. And lastly, the last panel here is about robotics. If you have a robot in a hospital or in a hotel, you want to be able to just talk to it and hope that it understands you. So in a hotel, say, bring me a shower cap, and tomorrow morning I want, 2 eggs over easy. So many different applications that could benefit from intelligent conversational AI. Now, the problem we have is that the current crop of chatbots are really not very smart. They don't remember what you said 2 sentences ago, never mind what you said, 5 minutes ago, an hour ago, or last month. So they don't have meaningful memory. They cannot learn interactively. So if you tell them something new, I've just got married, or I'm moving to Oregon next month, or whatever, they wouldn't know what to do with that unless they were very specifically programmed to look for that, those kind of keywords, so they don't learn. They have very shallow understanding because they use statistical keyword spotting and statistical matching. So they don't have a deep understanding. If you say anything more complex, it's easy for them to misunderstand. Even if you say, I hate Uber, don't ever give me Uber again, chances it'll still trigger the Uber app. Because that's like the closest thing. So they have no ability to reason, they have no common sense. So it's really impossible to have an ongoing, meaningful conversation with them and to be personalized to you. And just to concretize it, I'll show you, what is regarded often as the market leader, Alexa, trying to do some relatively straightforward things. And then after that, I will show you what's possible with the right technology that actually has a brain, a cognitive engine. So here's Alexa.
All right. Alexa, add chips and guac, napkins, and 3 bottles of wine to John's birthday list.
I added chips, guac, napkins, 3 bottles of wine to your shopping list.
Actually, Alexa, remove the napkins from the list.
To clear your list or remove an item, visit the Alexa app.
Okay, then. Alexa, what do I have on John's birthday list?
You have 1 item on your shopping list. Chips, guac, napkins, 3 bottles of wine.
You call all that 1 item? Oh, Alexa, remember that John's favorite cake is red velvet.
I'm not quite sure how to help you with that.
Yeah, so you can see there's no real understanding. It doesn't understand what list you're talking about, what items you're talking about, and therefore you can't change them. So what I'd like to show you next is a prototype we built 2 or 3 years ago, where you actually have a cognitive engine in the background.
Right, let's make this happen. Aigo.
Hi there. What's on your mind?
Let's add chips and guac, napkins, and 3 bottles of wine to John's birthday list.
Good morning, Sam. I don't know what guac is.
Oh, guac is the same thing as guacamole.
Okay, creating John's birthday list. Is that okay?
Yep.
I added chips and guacamole, napkins, and 3 bottles of wine to John's birthday list.
What was the food on that list again?
Chips and guacamole and 3 bottles of wine.
Actually, let's make that 5 bottles.
Sure. The list is now 5 bottles of wine, chips and guacamole, and napkins.
Great, let's send it over to June. And ask her if there's anything I'm missing, please.
Sending John's birthday list to June via email.
Wait, always contact June by Skype.
Okay, sending the list to June via Skype.
Oh, remember that John's favorite cake is red velvet.
Got it.
Fantastic.
Right, so you can see this is a very different experience. If Aigo doesn't understand something, it'll ask for clarification, can learn guac's the same as guacamole and then use it in the future. It can, ask for clarification. It can reason about things. And you know, it has some real intelligence. So you know, getting back to the key being, you know, we're talking about artificial intelligence. What does intelligence require? What do we expect of an intelligent system? We expect it to be able to learn interactively immediately, not that it has to go back to the factory to be trained with something. We expect it to have deep understanding, to have memory, to be able to reason, and to be able to adjust to different circumstances. If we had a personal assistant, if we wanted to hire somebody and they didn't have these attributes, you know, they wouldn't last very long. So, you know, I'll just give two e-commerce examples. You know, the Alexa one is obviously sort of consumer facing, but you know, these are some of the sort of typical things we've come across where you know, you might have bad spelling, or you really have to make sense of it. You know, order chocolate for my niece Amy May, can I add a card? To make sense of that, or if you can't make sense of that, to then ask for clarification requires really, you know, deep understanding and reasoning ability. Or tech support example, I'm only getting 20 now, I'm paying for 500. That's obviously the speed they're talking about here. Something most of us have experienced at some point. Already reset the computer and modem 3 times. You don't want the chatbot to just keep telling you to reboot the system if you've already done that. You know, and so to be able to really understand the way you expect an expert human to understand. So with the current crop of chatbots that are being sold by, you know, all the big companies and really hundreds of smaller companies, they really lack intelligence. What I'd like to talk about sort of in the rest of the talk are really 3 concepts, and I summarize them here because it can be a little confusing with levels and waves and things like that. So the first thing I'll talk about are 5 levels of chatbots. And that's basically the different categories of capabilities. The second theme is 3 waves of AI, and that is basically different approaches to artificial intelligence that have evolved over the years to help solve these problems in chatbots. And then the third topic I'll talk about very briefly is the difference between narrow AI and AGI, artificial general intelligence. So starting with the 5 levels of chatbots, as I go to conferences on chatbots, people are more and more now talking about these 5 levels, similar to the way you have 5 levels of autonomous driving. So where level 1 is, you know, something has been around for a long time, is just a notification. There's some simple trigger that sends out a notification, you know, like you might get emergency notifications of, you know, of that sort. The second level, which most of the chatbots out there at the moment are at level 2, is basically where you have a preset intent and response, so stimulus response type of thing, where you can say, you know, turn off the lights or tell me the weather. That kind of thing, where it just listens to the key, to the stimulus, and then has a canned response to that. Moving from level 2 to level 3, there's sort of some of them in between where you could say, you know, play Misty for me, or, you know, play whatever song for me, or turn off the lights in the bathroom, where it then needs to extract some kind of a parameter or multiple parameters, and where you may have some decision making. So that gets to level 3, and this is regarded as cutting edge of chatbot delivery right now. And companies are struggling to get those sort of things with complex flows working, where you then have decision points, where you have a lot of data that you need to gather. And you know, quite often these kind of level 3 implementations are not very successful, because you just have a combination of different, an explosion of different possibilities, and they really don't have deep enough understanding. So getting to level 4 and level 5 is basically where the aspects of intelligence, the crucial aspects of intelligence, start coming in. Is, you know, being able to learn unsupervised as you're having a conversation, that the system can learn, and that it has memory, short-term memory, long-term memory, that it can adjust the conversation as it flows, as the context changes. You know, 1 minute you may be talking something about business, the next minute you might be talking about something relating to your family. So that is level 4, and then level 5 is ultimately getting close to human level capabilities, where you have a theory of mind, you have metacognition, where the system understands what the other person's point of view is, where they're coming from, what they know, what they don't know, and having much more common sense knowledge. And sort of that's ultimately where we want to end up with. Now, the big message here is that, as I'll explain shortly, is there really is no upgrade path from the current level 3 technology that's being used to level 4. You really need to start with fundamentally a different approach. And this is where the 3 waves of AI comes in. Basically, we need a brain. We need a cognitive engine that can actually learn and reason. Now, some years ago, DARPA did some presentations about what they call the 3 waves of AI. So the 3rd wave of AI is basically what the brain is, but let me talk about 1st and 2nd wave. 1st wave is what many people refer to now as good old-fashioned AI. It's basically the first few decades of artificial intelligence were all about logic programming, expert systems, and flowcharts and things of that nature. Now, for conversations, to handle conversations, it's become very obvious that you can't really manage complex conversations by trying to manage them with flowcharts. You have a combinatorial explosion of possibilities, and it just doesn't work very well. So that's a first wave. The second wave hit us like a tsunami about eight years ago or so, when people figured out how they could build very large neural networks, field basically dominated by deep learning, machine learning approaches. And this has been incredibly successful. It's been able to, solve problems that have been intractable for a long, long time. And actually, most people today, when you talk about AI, only know about this deep learning, machine learning approach, the second wave. That's, that sort of seems to be almost synonymous now with artificial intelligence. Now, inherently, this approach uses big data, uses a lot of training data, and it builds models. So it's a statistical approach. It's been, it has been a real revolution in improving speech recognition, object recognition, which is, used in autonomous cars, and for lots of different things. And of course, very much for targeted advertising, which is, I guess, the sort of dark side of the second wave success. Now, however successful that is, people have over the last few years have started to realize what the limitations are of deep learning, machine learning, to the extent that the godfather of deep learning, Jeff Hinton, said that my view is to throw it all away and start over. That's how frustrated he is with the limitations. Or even the founder and CEO of Google DeepMind. Deep learning is an amazing technology, but definitely not enough to solve AI, not by a long shot. Now, that's quite an amazing statement to come from, the head of a company that has some, I believe, 600, something like 600 PhD level researchers working on deep learning. So there's, obviously something missing. And this is where we get back to the 3rd wave, what DARPA called the 3rd wave of AI. I relate it to cognitive architectures. Basically, it's having a system that is inherently designed to cater for the requirements of intelligence. What our brain structure has, it has inherently the ability to learn interactively, to reason, to be able to understand things contextually, to form concepts and so on. And that's really what you need in order to have intelligence in a system. Now, I came up with this design some 20 years ago when I did my original research. Over the years, people have tried to implement cognitive architectures, and they haven't been very successful up to now, generally, for some for a number of reasons that we've discovered and we've worked through. Basically, the various components need to be tightly integrated and work synergistically with each other, and you also need a very high performance knowledge graph. I don't have time to go into the details, but that approach, by implementing a cognitive architecture properly, you actually then get deeper understanding, you get memory, you get reasoning, and quite a bit of common sense ability. You contrast that to what everybody else is doing in the chatbot field right now, is basically using wave 2 and wave 1 technology. So on the left, you see a wave 2, a machine learning categorizer that if you say blah, blah, blah umbrella, it'll trigger the weather report. And then somebody writes a little flowcharty program that might ask you for when you want to know the weather for. So these two approaches of conversational AI, I really like chalk and cheese. The one is taught at the factory, and it only, whatever it knows was taught at the factory. It doesn't learn as it's being used, except, there's some minor exceptions to that. Whereas with the third wave, the system inherently designed to constantly learn and remember. Current approach requires a lot of training data that's labeled. So it's a quantity of data, whereas with the cognitive approach, it's the quality of data. It's having a much smaller set of data, but training the system in a hierarchical ontology. I don't have time to go through all of the other differences. I'll just highlight one important one, and that is the deep learning machine learning approach. Everything is a black box, so you don't know why the system gives a certain answer, and that has some quite important implications. That if the system can't tell you why it gives you a decision, then if something goes wrong, the only thing you can do is throw more training data at it and hope that fixes it without breaking other things. Whereas with the cognitive architecture, in principle, it's fully scrutable. It can tell you exactly, or you can figure out exactly why it's giving you a certain response. And if that's not right, you know that you need to give it very specific additional training information or business rules or whatever it might be. This basically really goes back to the difference between first and second wave, which is level 1, 2, and 3, versus the third wave technology, which allows you to go to level 4 and 5. And ultimately, for all of these applications, you really need a cognitive architecture. The applications, again, sort of just to highlight some of them, for hyper-personalized assistance, whether this is now via text or via voice, you can see them just many applications. I'm sure you could think of more of them. Finally, I'd like to talk a little bit about the future of where we're going, where I see us going with this technology. So first of all, let me introduce something that we call the personal assistant. And the reason I double up on the personal is, it really should be 3 personals, is the 3 different meanings of personal. The first one is something that belongs to you. You own it, you control it. The second meaning of personal is that it's personalized, it's customized to you, fits like a glove. The third meaning of personal is something intimate, private, so that you control what you share with whom. You may not want to share everything with everyone. So what you really want is you want this personal assistant that embodies the 3 different meanings of personal. Now, where we are right now, we really a far cry away from that. So right now, we interact with maybe Alexa, with Siri, with some bank chatbot, and then, for our bank balance, but then it'll be a different chatbot that can handle our mortgage or whatever. So there, dozens of different chatbots that we deal with. And the important thing is they don't learn, they don't really know about us in particular. There might be some database information about us, but typically it's just we're a demographic. We just fit into a certain bucket and they'll treat us a certain way. But most importantly is, they don't share information. Of course, you wouldn't want them to share information, but that also means if you change your address, for example, you'd have to tell, 20 different chatbots that your address has changed. But most importantly is they don't serve your agenda. They serve the corporation's agenda. Alexa is not going to tell you that there's a sale at Walmart, or Siri's not going to really go out of its way to tell you about some new Android phone. So, and similar with, other institutions, banks and so on. So it's not your agenda that's being served. So what I see in the future, in the next 3 to 5 years, what people will insist on is having their own personal assistant, something that acts as you can call it a co-pilot, or you could even call it an exocortex, an extension to your own brain. People talk about it as a digital twin as well, same sort of idea. But the important thing there, it's hyper-personalized to you. It really becomes part of you, and it serves your agenda. You control it. It's your data. You decide who you want to share things with. And it can then deal with these various other chatbots and services on your behalf. And, I really see that is going to be the future. That's the direction we're going. People are tired of, using these chatbots that might be free, but essentially you're selling your soul. Now, why don't we have that yet? Where's my flying car? We've been, talking about having this kind of personal assistant for a long time. And I'll finish off by just sort of highlighting the difficulty, the practical difficulty, or some of the reasons why we don't have that. Right over the last 7 or 8 years, where deep learning, machine learning has been so successful in solving very specific narrow problems like improving speech recognition, image recognition, and, as I say, targeted advertising, it sort of sucked all of the oxygen out of the air. So, everybody's working on machine learning, deep learning. You want to do a PhD? Well, that's the only game in town. It has to be on something related to machine learning. You want to get your company funded, it has to be that. So there's a sort of accident of history that the success of the second wave of machine learning has, pretty much worked to the exclusion of other approaches like the third wave and cognitive architectures. But there's also a more fundamental distinction between first and second wave on the one hand and third wave on the other hand. And that distinction is the difference between narrow AI and artificial general intelligence, where narrow AI, you try to solve one particular problem at a time. And what really happens is it's the humans, the data scientist, the programmer, whose intelligence in figuring out how to use technology to solve that problem and then turn it into code or turn it into a trained model. So it's the external intelligence that is frozen in some piece of code or in a data model. Whereas what you really need for a system to be adaptive, to be able to learn and improve and deal with changing circumstances, to be able to use something it learned in one domain or in one context, to be able to use it in another domain or context, there the intelligence actually needs to be in the system itself. Internally to be adaptive. And that is really what artificial general intelligence is all about. And we need a cognitive architecture to achieve that. Now, why aren't more people working on that when it's so obvious that intelligence requires this third wave thinking? And the reason for that is commercial pressures, basically, commercial and academic for that reason. For that matter. So if you're trying to show results quickly, it's almost always quicker and cheaper to use the narrow AI approach, to basically for some smart person to figure out what algorithm to write or how to use various algorithms or how to build a statistical model that will solve that particular subset, narrow subset of problems. So, you know, if you're trying to beat benchmarks in order to make progress in academia, a narrow approach is more likely to get you there. If you're trying to get the next product out the door quickly, a narrow approach is likely to get. So I call that the narrow AI trap. I've seen this quite a few times where companies or research teams have tried to implement something sort of in the AGI way, in the cognitive architecture way, and then basically commercial academic pressures have pushed them into the narrow AI field. So you really have to have a deep conviction of what intelligence truly requires, and you need to have enough of a long-term vision to do it the hard way. That will ultimately give you the benefits. So I think that's all I have time for, and I have opened for a Q&A. I have quite a number of articles I've written on topics including AI ethics and ethics in general, and intelligence and third wave and so on, and you can find them at this link here. So I think I'm open to questions now.
Thank you, Peter. Great product and great sharing about cutting edge technology. So yeah, we do have great questions from our attendee. One attendee named Shmuel from Israel asked, I would like to ask a question. If idea of chatbot with brain, that's that chatbot basic artificial intelligence can do to help in fighting against hackers and other forms of cyber attacks? Thanks.
Yes, certainly. Now, I don't want to, oversell what a chatbot with a brain can do at this stage. We are certainly nowhere near human level intelligence at this stage. So there's always one has to look at each particular application and what you're trying to achieve. If you're trying to ultimately achieve moving the field forward and getting, better and better chatbots, then clearly one needs to work on cognitive architectures and AGI. But if you're trying to solve a particular problem, like cyber attacks or whatever, and that's your focus, you may just be better off using various techniques and using the intelligence of the program as a data scientist. Now, having said that, in the longer run, these cognitive architectures will also be extremely powerful at being tool users. So, why I don't expect the cognitive architecture, general AGI architecture, to, out Google or to become the world chess champion or Go champion. What they will be able to do is to use a chess program or Go program or to use Google effectively. So like humans, they'll become tool users. So in your particular examples, cyber attacks or any other narrow application, these intelligent chatbots or assistants will become really good at being able to use a variety of tools, knowing which tool is the best tool to use. And of course, they'll be able to try lots of different tools and won't get tired and bored like humans do. So they'll be much better at actually getting the most out of the various tools and technologies that are out there.
Thank you, Peter, for the answering. So another audience.
Can't hear you.
Oh, better now? Okay. What about now?
Okay, I can't hear you. I can read the questions and answers. Maybe I.
Is it better now? No?
All right, let me maybe go through the list. So the risks and dangers of over-personalizing narrow AI is one of the questions I read here. I'm not quite sure what you would mean by over-personalization. I think to me it comes down as a matter of intelligence, and people often ask about bias and things like that as well. To me, typically these problems are just bad engineering. I mean, we've had, bias in loan applications or whatever a long time, over personalization where the system assumes something that isn't true about you. Um, also there's the whole, obviously with social media, we're very aware of that in-group thinking, that something that a narrow AI could, or an AI generally, could just present you things you want to hear, or, to kind of reinforce your existing thinking and preferences. But to me, these are really just failures of engineering and sometimes it's done on purpose. But yeah, I don't see that over personalization as such. I think the problem is that we all experience is that chatbots and experiences that we have with generally support are not personalized enough. They don't know our circumstances. They don't remember conversations we've had before, and so they become very frustrating. Possible to get recording and slides? I imagine so. Certainly, I can make them available. As I said, on the link that I gave, or you could just search for my name, Peter Voss, on medium.com. There's a lot. We'll go to our Aigo.ai website. There's quite a lot. Okay, somebody says AGI approach seems very vague and not well defined. Yeah, I think reading my articles on that should hopefully give you a better understanding. I've written quite a bit defining intelligence and artificial general intelligence, why we need the term, and specifically what it is. Yeah, I don't know. Unfortunately, I'm not able to hear. Are there any other questions?
Yes, we got another question from
Okay.
Oh. Can I hear? Hi, Peter.
Okay, now I can hear you.
Okay, great.
All right, something must have gone wrong with my system when I just, yeah. Anyway.
So we have more upcoming questions for you. So one attendee called Gazala said, your thoughts on intelligent systems like we're seeing generative design technology in architecture industry is introduced. Do systems be customized in future?
Yes, absolutely. It's sort of something I mentioned earlier, is that I see these AGI systems, these personal assistants or just general assistants, which can obviously be focused on things like architecture. They can be domain experts. In fact, I would expect systems to be trained to be that, would actually be fantastic to interact with the various VR, AR, and tools, design tools that are out there, so that you could basically explain to the system what kind of building you want, and it could use the tools to put this together, show it to you, and then you could say, no, I want, I don't want the bedroom facing this way, and it can then go in and make the changes, or change the color of the wall, or make this bigger, or whatever. So you could have this interaction with the system, and it could be taught to know how to manipulate the various pieces of software that actually generate designs. So I think that'll be one of the kind of really great uses for this technology.
Great. I will have another question. Nan. She said, can you show your last slide again for future reference?
Oh, okay. Let me get that. Let me get that up. All right. That's the reference slide, Aigo.ai resources. Is that the one you're talking
Yes.
about? Okay.
So thank you. And another question from Joe Angeles. If humans do not understand and cannot control how AI manifests themselves in algorithmic bias and dangerous feedback loops, should we be concerned?
So I think the problem, I have written quite a bit about the dangers of AI as well. And unfortunately, a lot of the thinking that's happening right now about AI is obviously focused on machine learning, deep learning systems. And these systems don't actually have any real intelligence. They don't reason, they can't adapt, they don't learn, they don't have deep understanding, they don't have grounding. So there are things that can go wrong in these systems that an intelligent system simply wouldn't happen. So on the other hand, because they are limited, they're narrow AIs and they're limited in their intelligence, they can also not cause as much damage. So I believe very strongly, and again, I've written about that, that more intelligence is actually will reduce the risk, because a lot of things that are done that are wrong and dangerous are because of lack of intelligence. And you can see that in us humans. Basically, we tend to do a lot of things that we regret for really three reasons. One of them is that we react emotionally. We do something, as an emotional reaction to something, which a smart AI would not. Secondly, we don't have all the knowledge. We don't have enough knowledge. We often make decisions on very limited knowledge because it's hard for us to gather a lot of knowledge to integrate and so on. An AI inherently will have much more knowledge and be able to get much more objective, correct knowledge, because it'll be able to cross-check different sources without emotions getting in the way, without sort of selection bias. And thirdly, we are actually not very good at logical thinking. It's sort of just something that's a byproduct of evolution. We weren't really evolved specifically to think logically. And an AI, of course, will be much better at that. So having this crisper intelligence available to you, I believe will actually improve the human condition and reduce risks significantly.
Thank you, great answers. Well, we have more questions for you, but we are almost run out of time. But I can get one more question or one or two questions. So Arjun said, I really like the application of Aigo as a personal assistant, the external cortex. Do you have plans for Aigo as a enterprise product to interact with customers, learning about individual customers' preferences, etc.?
Yes, I'm glad you asked the question. That's actually what our company is focusing on right now. So we are working with large enterprise customers exactly for that reason, to provide a hyper-personalized concierge assistant, whether it's for buying products, whether it's for support, or internal use within the company, customer facing, whatever it might be. And that is actually the main focus right now, where we are able to offer a much better experience and a hyper-personalized experience. Imagine calling into a company and the person you're talking to remembers the last discussion you had, knows everything about you, and can instantaneously give you the answers you want. But for that you do require intelligence. So yes, that's what we're focusing on.
Yeah. Thank you for the answering. So maybe one last question. If you have more questions, you can always email us at the conference email, and we can get back to you after asking Peter. So one last question. Are there any interesting new potential use cases that the current pandemic has brought up to light?
Well, more generally, people are obviously much more focused on automation, and especially in call center, because it's very hard to get people to come in and work. A lot more people are working from home. So a general push towards automation. I wish I could say that AGI or cognitive architectures are at a point that they can really help with the science of a pandemic, but we're really not there yet. But in terms of just making it easier for people to get things done from home, and without actually physically going to stores and being able to interact with company electronically, absolutely, there's a big demand for our kind of technology.
Great. So yeah, we do have more questions, but ran out of time. So thank you, Peter. Thank you so much for your answering, sharing the cutting edge technology and the great products. So if you have more questions that you wish Peter can answer, please reach out to Peter directly or reach out to the conference at Ideas. Thank you, guys.
Well, thanks for having me. And yes, you can find me on LinkedIn and Medium and so on. So I'll be happy to answer questions. So thanks for having me.
Thank you, Peter.
Bye.